Check your heater right now. Maybe it's on. Maybe you barely thought about it when you turned it on this morning. But for over 300,000 years, every single one of your ancestors faced the same problem every winter. No heater, no insulation, no walls, just their hands, animal bones, and a cold so savage it would kill a modern human in hours. So how did they not just survive, but build, create, and outlast one of the most hostile climates in planetary history? The answer is not what you think, and it will permanently change how you look at winter. Let's start with what the cold actually felt like. We're talking minus 40 degrees Fahrenheit on the Eurasian steppe. Not the cold you feel walking to your car, not the cold that makes you pull your jacket tighter and walk a little faster, the kind of cold where exposed skin begins to die within minutes, where breathing hurts because the air itself is damaging your lungs, where the wind doesn't just chill you, it hunts you, where frostbite sets in before you've had time to realize something is wrong. A modern human dropped into an ice age winter without preparation would likely be dead before sunrise, not struggling, not uncomfortable, dead. The image most people carry is always the same. Shivering cave people hunched over a tiny fire, barely making it through the night. One bad storm from extinction. But archaeology tells a completely different story. A story of engineers. Here is the first thing almost everyone gets wrong about your ancestors. They mostly didn't live in caves. At a site in Russia, dating back 800,000 years, researchers found circular depressions cut 8 feet deep and 12 feet wide into the ground. Not natural formations. Tool marks in the soil proved they were deliberately excavated to those exact dimensions. Why? Because at 6 to 8 feet below the surface, ground temperature stays 20 to 30 degrees warmer than the air above it. Your ancestors didn't fight the cold, they went below it. But the real sophistication came later. At Dolní Vianoce in the Czech Republic, 26,000 years ago, archaeologists uncovered winter shelters with walls built in multiple distinct layers. Innermost, animal hide, fur facing inward, trapping warm air directly against bodies. Outside that, dried grass and moss, wicking moisture away before it could freeze. Outermost, woven mats of reed and bark, wind-resistant but breathable enough to let moisture escape before it destroyed the structure from within. This was not primitive guesswork. This was deliberate, layered thermal engineering. The exact same principle behind the insulation in your walls right now. Different materials, identical physics, and then archaeologists found something that stopped them cold the first time they saw it. In Ukraine and Russia, at sites like Mezherish and Kostenki, researchers uncovered actual buildings, not caves, not windbreaks, engineered structures built entirely from the bones of woolly mammoths. Picture this, mammoth skulls, each weighing over 200 pounds, arranged as foundation blocks. Curved tusks, some over 10 feet long, tusks bent into dome frameworks and locked together at the apex. Hundreds of smaller limb bones packed into the gaps for structural support. The entire structure then covered in layers of stitched mammoth hide, thick enough to stop wind completely, shaped precisely enough to shed snow without collapsing. Experimental reconstructions of these structures have confirmed what the archaeology suggested. A properly built mammoth bone house maintained interior temperatures 40 to 50 degrees warmer than the air outside, using only modest fires. Modern Arctic shelters with industrial insulation and electric heating have performed no better. Let that sink in. Stone Age builders using bones, hide, and stone tools match the thermal performance of modern Arctic engineering. But none of this worked without fire. And fire wasn't just warmth. It was the entire operating system of Ice Age survival. The thing every other system depended on. The heating layouts inside these structures were not accidental. A central hearth provided primary heat. Smaller secondary hearths positioned around the perimeter created designated warm zones for specific tasks. Food preparation in one area, tool making in another. Infants and elderly placed nearest the warmest spots. Every position in the shelter was a decision. On the treeless steppe, wood was scarce and unreliable, so your ancestors developed alternative fuel systems. Mammoth dung, dried and carefully prepared. Bone, processed specifically to maximize burn efficiency and heat output. Chemical analysis of hearth residues from multiple sites shows these fuels were deliberately treated before burning, not thrown onto a fire as found, but engineered for specific thermal outputs depending on the task at hand. They were not burning whatever they could find. They were managing fuel as a carefully rationed resource, the same way you manage a budget. And then there was ventilation. The detail that genuinely surprises modern Arctic engineers when they study these sites. Without proper airflow, moisture from breathing, cooking, and multiple bodies accumulates inside any enclosed shelter. In sub-zero temperatures, that moisture freezes. Ice forms on the inner walls. The insulation saturates. The structure fails from the inside out. Archaeological evidence at Kostenki shows carefully designed passive airflow systems built into the structure itself. Small openings near ground level pulled fresh air in along the floor. Larger openings near the apex allowed warm, moisture-heavy air to escape upward and out. The same convective airflow principle used in modern passive building design. 20,000 years before building codes existed, your ancestors had already solved the ventilation problem without any instrument to measure airflow, humidity, or temperature. Now, here's the part most people never hear about, and it's the part that changes how you think about these people entirely. Building a mammoth bone structure took 2 to 3 weeks of intensive work by 8 to 10 adults, which means construction had to begin in late summer or early autumn. Weeks, sometimes months, before conditions made outdoor work impossible. Miss the window and your group doesn't have shelter when the temperature drops. Miss the window and people die. Analysis of tool wear patterns and seasonal bone deposits at these sites confirms it. These were not reactive builders scrambling when the first snow fell. They were planners running precise seasonal construction schedules entirely in their heads, without written calendars, without any external tracking system beyond the position of the sun, the behavior of migrating animals, and knowledge accumulated across generations. They knew winter was coming before winter arrived, and they were ready for it. Food storage was equally engineered. In permafrost regions, underground chambers connected to winter shelters by short tunnels served as natural freezers, keeping meat from a successful hunt preserved and accessible for months, even through the worst storms. These weren't accidental features. Archaeologists have found the pits, the connecting tunnels, the bone deposits inside them. Ancient humans understood that the frozen ground preserved food, and they built their entire winter food supply around that understanding. Clothing worked on the same layered principle as the shelters. Multiple hides, each selected for a specific thermal property. Wolf fur, fox, Arctic hare. The innermost layer trapped warm air against skin. The outer layer shed wind and moisture. Bone needles from this period have been found as small as 7 millimeters, finer than many modern sewing needles, used to stitch precisely fitted multi-layered garments with sealed seams. The same physics as a modern performance winter jacket, developed independently. 25,000 years before Gore-Tex, when the shelter was damaged, and it frequently was, it was repaired immediately. Archaeological evidence shows continuous maintenance throughout winter seasons. Broken bones replaced, hide coverings patched, insulation refreshed. This wasn't a structure they built and hoped would last. It was a living system they managed daily. At the end of the Ice Age, as temperatures rose and forests expanded across Europe and Asia, this entire knowledge system was gradually abandoned. Not destroyed by catastrophe or war, just slowly made unnecessary as the world warmed and the extreme conditions it was designed for ceased to exist. Modern Arctic engineers studying these sites have been genuinely surprised by what they found. Military Arctic survival programs now teach shelter-building methods derived directly from archaeological reconstructions of these 20,000-year-old designs. Disaster relief organizations have adapted the same layering and ventilation techniques for emergency construction in extreme cold environments. We lost the knowledge entirely, then spent a century rediscovering it with modern science, satellite imaging, and experimental archaeology, and found out that our ancestors had already solved it perfectly, using nothing but bones, stone tools, and a deep understanding of the physics of heat and cold that nobody had taught them. Go back to your heating. The temperature in your home right now represents something your ancestors would have considered impossible. Not because they couldn't achieve warmth. They could, in conditions far more extreme than anything you will ever face in your lifetime. But because achieving it cost them everything. Every warm night required weeks of preparation, months of planning, continuous physical labor, and an engineering precision so exacting that a single structural failure, a gap in the hide, a collapsed bone joint, a blocked ventilation opening, could mean a family frozen before dawn. You didn't invent warmth. You inherited it from the most resourceful engineers who ever lived. People who had nothing but cold, time, bone, and an absolute refusal to give up or die. The next time winter comes and you reach for your heating without thinking, without even registering the action, remember what it actually cost to get here, and understand, maybe for the first time, how extraordinarily rare it is to be warm.